Hello everyone, Sean, welcome back to the channel. I have in front of me a couple PA system Peavey speakers, model Impulse 6 watt / PR is what's written on here. You can see the serial number, all that information as well. These, I believe, are supposed to be 8 ohm speakers according to technical manuals or spec manuals I found online. They have passive crossovers in there, so we'll see some form of capacitor or resistor combo acting as a crossovers. But these speakers do not output a lot of audio, and we're going to take them apart and see if we can find replacement speakers to put in here just to get them back operational. So at the input, let's see, we're 0.8 ohms on this input. Should be seeing 8. And this one, what is that? And climbing 1.4 meg. So obviously we need to take these out and see what's going on in there. As a matter of fact, if I was to take my signal generator and just apply, let's see, do I have these oriented the right way? No, I do not, according to the plus and minus signs. I highly doubt we get any loud audio. Yeah, you're probably not hearing that at all. Let me turn off the filters for a second. Yeah, whether or not you hear that. So that's with a 5 volt peak to peak input. And we're up to 20 there on that one. 20 volts peak to peak. And it's much the same. All the way up to 20 volts peak to peak. Should be screaming right now. But not really hearing anything, because these speakers are just bad. Super bad. So most likely that's going to be the voice coil. But we'll take these apart and see what needs to go into them. Alright, so a little bit of different construction than I was originally thinking it was going to be. So what Peavey is doing is they're making a little PCB board with an inductor with ferrite core, transformer, 2 non-polarized electrolytic capacitors, and then 7 watt 5 ohm resistor, pretty hefty resistor. And they're building in a way to where they can tap audio over to 2 different speakers, and also it is also functioning as a crossover. So the issue might not be with the speakers, it could be with this right here. So let's go back through, let's do a resistance check again across the coil. And I'm getting, what was that? 6 ohm across the coil of this speaker, and that's perfectly fine. And when it was connected to this, it was measuring 0 or 0.6, I want to say. Let's see. Yeah, now we go to half an ohm. So the issue is most likely going to be on this board over here. Let me check this one. No, the coil on this speaker is most definitely blown. 0.2 ohms. That's not good. This should be a 8 ohm speaker. So we're going to have to replace this guy, unfortunately. We got two problems in. This is a problem, and that's a problem. Well, what I can do, so let me go back and just connect these two things. I'll take this down to 500 millivolts peak to peak. We'll just listen. Yeah, I would call this one good. That's the only speaker that's working on it. What happens when I plug into this guy? Probably nothing. Yeah, I get nothing there. So my question is, what am I measuring in here and out these terminals here? Let me hook up a few things. Okay. You can see my oscope right there. I've currently got my SIGGEN producing a 1 kHz tone at 1 volt peak to peak. I have it hooked up to the oscope, and you can see that sine wave right there. 1 kHz, approximately 1 volt peak to peak there. Okay, so what I'm going to do is I'm going to decouple my SIGGEN from my oscope probe. Okay. Then I'm going to take the signal generator to the input terminals of this crossover, and we're going to measure the output. The yellow and blue went to this larger 8 ohm speaker sitting right there. Okay, so let's see if what output we have. Well, I think I'm going to take back my initial assumption of these crossovers. I've torn this one over here apart and took the electrolytics out and just did a capacitance check on them. They're pretty close. I'm going to replace the electrolytics on both boards regardless. And going over the topology and the components, resistor is reading 5 ohms. I've got about a 1 ohm resistance across the inductor. About 1 ohm of resistance across the transformer. These two pins that you see right here for that white transformer. Okay, and you know, those components, I would expect low resistance across a coil because it's it's there to induct. Really, virtually you would have 0 resistance across a coil. But so those components in my head, I believe they're perfectly fine. Just like I did with the previous one. So I've got 11 volts coming out of my SIGGEN, and I'm going to what would be plugged into the 8 ohm speakers, and they are 8 or 6 ohm. I don't know. They're measuring. The output is 4 volts peak to peak out at 11 volts in. And so the issue with what I was doing is, because this is dividing, for lack of better words, uh, the input and output across two different terminals, I mean, you're just not going to have a one for one in and out, um, given the composition of our components here. So the issue is most likely not with these crossovers. And again, if I was using well, that sine wave is looking pretty bad. That's typically a transformer or a capacitor issue. I can't really get up to the AC voltages that would be used on this because we would be more closer to about 40 volts, I think. But I don't believe that the primary issue is with these crossovers. I believe that it will be with the speakers. And by the by, speaking of speakers, well, the one that we had, let me get some of this stuff out of the way. Hate it when I get my desk too messy. All right, so this speaker right here, we had it was voice coil was pretty much shorted. Yeah, 0.3 ohms. This speaker over here, the voice coil is completely open, and so yeah, there we go. Open voice coil. If you can see it there in the bottom left corner. Shorted voice coil, 0.3 ohms. So the issue is going to be with these two main speakers. That's what blew. So I'm going to get replacement capacitors. You know, they're older electrolytics. They should be replaced anyways. And then I'm going to get two replacement speakers. This tweeter was fine. And once I get all the replacement parts, we'll put them in and see how it does. I decided to tear down these speakers a bit, just to kind of give a general sense of what is occurring here. Yeah, these were definitely had a massive surge of energy go through them. As a matter of fact, the diaphragm on the speaker was stuck outwards, and I had to push it to pop it back in. And here, listen. It's pretty crunchy. Okay. It tells me we got rubbing in the voice coil and stuff. Yeah, the voice coil itself, I typically, when I have old speakers, I like to pull out this old enameled wire because it's good for using with circuit pairs and stuff. But the wire in this, if you will notice, is all black. It is burnt up. So the enamel could have possibly still be good on this, but you know, these are burned up wires. I might save this. I might be able to spool this up, clean it up, and use it in other applications for something. You know, it's very thin copper wire, and that comes in a significant amount of use in PCB trace repair and stuff. So I can take this utility knife here, and we could do the exact same thing with this guy here. You know, I have no use for repurposing the cone. We don't have to cut it. We can actually just peel this one up like this. So the cone is diaphragm itself is it's in pretty good condition. We're going to be pretty destructive. There we go. There we go. So all that's left really is let's see. Let's cut out the spider. Typical paper spider on this guy. Yeah, we'll go all the way around. right, do I have it all the way across? There we go. Cool. And can we pull out the voice coil on this one? And there it goes. Yeah, and you can see burned up as well. And when these things get hit by high power like this, they kind of have a non-pleasant aroma. Smells like cigarettes. Yeah, it smells like an ashtray. This is what it is. Now, as a replacement speaker, actually this one made in Taiwan, the original speaker, part number 70777-109, written right here on the back of the magnet. Realize that's reverse, but oh well. The replacement part we're going to use is this GW TAC 205/8 Sierra. You see right here, I got these off of Amazon. Very similar speaker design as far as the diaphragm goes and the spider underneath construction. Voice coil without cutting it open would be very similar, I would assume. The only massive difference is our permanent magnet speaker that we have down here. Generally speaking, your voice coil construction and the materials that are used, even the diameter and the size of your magnet's going to determine a few things for you. You know, how much wattage speaker can is rated for, you know, its RMS and peak voltage, what it can withstand. You know, in a general sense, I'll say, if you've watched some of my radio videos, you'll see I talk about how a speaker functions and etc. I would expect that as far as frequency response and sensitivity, you know, you would kind of say that a bigger or heavier magnet is going to produce a speaker that is more sensitive, so it'll probably have a better frequency response but that's not always the case. It's not so much weight as it is more type. I guess I could put it that way. Neodymium magnets versus any other metal alloy or something along that line that has been built to be a magnet, right? Or been magnetized, right? Okay. And even when it comes to building a speaker that you know, is, you know, more sensitive or more powerful, there is a point when you get diminishing return. Okay, so yeah, you could have a stronger and bigger magnet on a 5.25 inch speaker such as, or woofer such as this one, and that might you know, help with frequency response and sensitivity, but at some point in time your magnet's strength is going to have an inverse effect on you know, dampening, right? So you'll have to have a stronger signal in to overcome the polarity of the magnet, to overcome the forces that are produced in order to get the speaker itself to produce sound. I guess I think I could put it that way, if you're following. That's at least my 2-cent version. So is this speaker going to sound different from what was used by the original manufacturer? Most likely, yes. I got this one because I believe it's rated for a higher power rating than what originally came out. You know, we're going to replace the non-polarized electrolytic capacitors on the crossovers as well. But I imagine it's going to be pretty close and, you know, a slightly higher power rating. So you know, hopefully we're not blowing this one anytime soon, barring of course an electrical storm, lightning coming in and basically destroying PA equipment. So this is what I'm going to be using to put back in the speaker, this GW TAC 205/8 Sierra speaker. I've got multiple of these. They are a bit longer in depth than you can see width, but I've already mocked them up and they should fit inside the box perfectly fine. So this is a point where I am going to record working on the crossovers, getting the capacitors replaced and our replacement speakers put into their boxes. Hello everyone. For those of you who are having to be watching this video today, you know here in the States we are currently celebrating Thanksgiving. And so I kind of wanted to stop. I hardly ever release videos on holidays themselves because, I fully believe that this is a time to be spending with your family, not really online. But, given an opportunity with an occasional video to come out, I think it's a great opportunity for me to, take a second and pause and express gratitude and thanks. For those of you who watch my videos, I don't hide it. You see a lot of you may have seen a Bible or a hymn book laying around, and I find that most of my customers end up attending a church somewhere. And so even scripture, it tells us, like in 1 Thessalonians 5:18, in everything give thanks, for this is the will of God in Christ Jesus concerning you. And so when I reflect on that, I look over the past year, me retiring from the military, coming back to work in the DoD as a civilian instructor. And then, all of you who joined this channel, you've made it what it is as far as channel growth, and all of you who liked and comment and share these videos. It's just all amazing to me. And so, that's basically it. I just wish everybody, good, happy holidays, a happy Thanksgiving. I hope that the remainder of your year is everything that you would hope it would be. And hey, if you ever find yourself down here in the, one of the hottest states here in America, down in the South here in Mississippi on the coast, and if you ever need a place where you can just come and want to visit and hang out with Sean here at HFR, even my family, you're more than welcome and invited to attend First Baptist Church, Windsor Park, off of Washington Ave. You might even catch me singing in front of the church, leading all the music ministry. All that being said, thank you for watching this video. Thank you for being a part of this channel and this channel's growth. And again, I wish everybody a happy holiday. Both speakers put back together. I've devised a very simple test using my signal generator over here. We're setting each channel to start with 4 volts peak to peak at a 1 kHz tone. I'm going to turn on channel 1, and we hear that 1 kHz tone. Let's change the amplitude. It's no longer quiet, it's very loud. And as I increase amplitude, it definitely gets louder. Now with a quick amplitude test out of the way for channel 1, let's turn it off, and I'll switch over to channel 2, still 1 kHz tone, 4 volts peak to peak. Let's turn on channel 2 and increase the amplitude of the incoming signal. I max out at 20 volts peak to peak. Obviously a PA system is going to push higher voltages than that out, but that is working pretty well too. So maybe we can create some dissonance and harmony and all that stuff. So why don't we just go through and I don't know, let's change tones. 20 volts frequency. Forgive me, I was changing channel 2. There's 20 volts. we go. Well, if you've enjoyed this video and going along the repair with me, please let me know by leaving a comment or liking this video. If you're new to this channel, since you're already here, why don't you go ahead and subscribe. If you're in need of repairs from Having Fun Repairs, HFR, visit the business page. Link is in the doobly-doo down below. But as always, thank you for watching. Take care and goodbye. Bark.